Assalamu alaikum students. I hope you all are doing very well, and the topic today we are going to study is calculation of energy of an electron in an orbit. We are going to use Bohr atomic model for derivation of energy of an electron in an orbit. So let's see how we are going to use Bohr atomic model for calculation of energy. So we say that an electron possesses two kinds of energies. One of them is kinetic energy and another is potential energy. Kinetic energy is required for motion of an electron in an orbit. If an electron does not have kinetic energy, then that electron cannot move. And another is the potential energy. From where potential energy is coming? This is coming by interaction of electron with nucleus. So kinetic energy is equal to half mv square, while for the derivation of potential energy we use the formula that minus force multiplied by distance. As we know, distance between nucleus and the electron is called radius, so that's why we have written radius here instead of distance. So here is the sign of force. Then what kind of force exists between nucleus and electron? Because we are talking about that potential energy is by virtue of interaction of electron with nucleus. So we know that nucleus has positive charge because of protons, while electron has negative charge. So there is always attractive electrostatic force of interaction between positive charge and negative charge. There is always attractive force. So as we have discussed the attractive force, which was a kind of centripetal force, while we were deriving the radius of an shell. So I am going to put the formula of that electrostatic force here, which is equal to minus ZE square divided by 4 epsilon naught R square. So we can see that here is R, which is going to cancel the R square. So R square is cancelled, and we write on that minus ZE square divided by 4 pi epsilon naught R, which is equal to potential energy. So we can say potential energy is equal to minus ZE square 4 pi epsilon naught R. So I am going to write down here potential energy, while we have seen that formula of kinetic energy is equal to half mv square. And now the total energy of an electron we can say that is the sum of kinetic energy plus potential energy. As we know, kinetic energy is equal to half mv square, so that's why I have put here half mv square, and a potential energy was equal to minus ZE square divided by 4 pi epsilon naught R. We are going to balance these charges. As you know guys, that plus and minus sign is always equal to minus, so that I have put here, and other are like before, half mv square minus ZE square divided by 4 pi epsilon naught R. The equation of mv square has been derived from the radius calculations that we have discussed before in previous lecture. So mv square was equal to ZE square divided by 4 pi epsilon naught R. So this equation was named as first equation. So by putting mv square values in first equation, we can get half ZE square. You can check that instead of mv square we have put its formula. So here is ZE square 4 pi epsilon naught R minus ZE square 4 pi epsilon naught R, which is already here in first equation, and this is coming from mv square value. This is coming from mv square. So we can see that the whole this part of on one side of equation is the same as on other part of the equation, so we can take both part as common. So that's what we have done here. We have taken ZE square divided by 4 pi epsilon naught R square as a common, and then negative sign is coming here. So now our equation will become, by multiplying our 4 digit with 2, it will become equal to 8. So minus ZE square 4 into 2 is equal to 8. Others are as same, pi epsilon naught r. So till now we have calculated for energy. But as you can see students, I have encircled this r because z e square 8 pi epsilon naught, these all digits are constant, while r is not constant because radius of one shell will be different from radius of another shell. But charge on proton or the proton number of an atom, similarly vacuum permittivity, these will be constant values for an atom. And we also know that pi is also a constant digit, and pi is also a constant, and 8 is also a constant digit. So now we can put the formula of r here because r is variable, and we have already derived r by using Bohr atomic model. So we are going to put the formula of that r here in this equation. So I can name it as a equation 2. So in equation 2 we are going to put the formula of r. Last time we have calculated that r is equal to n square h square epsilon naught divided by pi m e square z, right? So I have written the formula of energy. Other parts are same, like minus z square 8 pi epsilon naught, because these are constant. I am going to keep it as it before. So now you can see that I have replaced r with this formula, n square h square epsilon naught pi divided by pi m e square z. As you know, this value cannot exist here, it will come upwards. So I have done this pi m e square z. You can see it has come on the top of equation, and n square h square epsilon naught that will remain here, and it must be multiplied with already existing values. So here it is the another equation, and now you can see that there are two z. So you can multiply z, it will become z square. There are two e square, so you can multiply both of two e square, so it will become e4. Another is pi m divided by 8 pi epsilon naught n square h square. But here you can check that it's epsilon naught square because in denominator there are two epsilon naught. So we have multiplied both of them, then these will become both of them will come in the form of epsilon naught square. So I have written this equation here, minus z square e4 pi m divided by 8 pi epsilon naught h square. But I have taken out n square from this equation because n square is variable. Okay, n square is variable, while all these digits are, all these formulas are constant, and by putting value of these constants we get a product of 2.18 multiplied by 10 to power minus 18 joule. Here you can check that I have written the constant ones, z square e4 pi m divided by 8 pi epsilon naught square h square, which are same in this equation. I have named this equation as equation number 3. So I have taken out the constants digits, and I have put their value here. But I have not put here 1 by n square because I have told you students before that n square, or you can say principal shells, are not constant. So that's why we are going to put the value of these constants that I have written here and multiplied by 1 by n square. You can also check here, instead of this formula I have put the value of this and multiplied by 1 by n square. So similarly I have done it, and the formula is joule per atom. For this, because we are going to calculate energy for n shells, so here the unit of En is joule per atom. If we want to convert them in kilojoule, I have also told you in a lecture that we can multiply it by Avogadro number and divide it by 1000. So unit will be changed to kilojoule per atom. Now it is changed from joule per atom to kilojoule per atom, but its values also changed. Now here it is 1312.36 divided by n square for the you can say n number of orbit. Here energy can be calculated by using this formula. So thank you, student.